All right, chapter 5 begins. 2 vocab terms. That's where we begin. Huh? So, as we all know, chapter 5 deals with fractions. So, the first handful before the quiz, we're not really going to be doing any order of operations stuff. It's just least common multiple, greatest common factor, and prime factorization. So all stuff we've done before. So the 2 terms we're talking about are prime numbers and composite numbers for vocab. Vocab, these 2 terms, here we go. Prime numbers. Prime numbers have exactly 2 factors. 1 and itself. Those are the 2 factors. So when I'm saying factors, what's a factor?
Like the numbers that go into it.
Into what?
The numbers.
Multiply.
Yeah, that.
Right. So when we're talking factors, I need 2. I mean, if I just write a number down, that's not really a factor because it's just a number. So factors, though, you got to multiply, and to multiply, you got to have at least 2 things to multiply together. So if I take a number like, say, 7, all right, and I say, well, what times what is 7?
1 times 7.
1 times 7. What is
2 times 3.5.
whole numbers?
Oh, 7
But
times
yeah,
1.
that's true. And that's about it. Or 7 times 1. The order doesn't matter. The number 13.
1 times 13.
Yeah, or 13. Yeah, right. So these are examples of prime numbers because the only factors or the only multiplying combination that exists to get this for an answer is whatever that number is times 1. There's no other way using whole numbers to multiply and get these answers. Agreed? Prime numbers are a huge deal in math. Not just for fractions here, but they have much broader applications starting next year when we take our algebra up a notch, and then we're also going to introduce the concept of polynomials to you next year, and you're going to prime how we simplify. It's next year stuff, but this concept goes beyond fractions. For now, we're just going to be applying it with fractions to get used to it, but prime numbers have tremendous significance because they can't be broken down any further. So what I need you to know are prime numbers. I can, if you need it, I have little lists I give the 5th, sometimes the 6th grade. Last year I gave you the list with 1 through 100, shows which are the prime numbers, which are not. So I can show you that. The other type of number, composite. Composite numbers have 3 or more factors. So if I take the number 6, what times what is 6?
1, 2, 3.
1 times 6,
Not 4 or 5.
but it's also 2 times 3. So the factors of a prime number, if I say what are the factors of 7? The factors are 1 and 7. The factors of 13 would be, and again, the order you write them doesn't really matter. But if I say what are the factors of 6? Well, 1 times 6 is 6, 2 times 3 is 6. So if I say what are the factors of 6, you would say 1, 2, 3, and 6. All 4 of those would be factors of 6. All 4 of them. What about the number 9?
1, 3, 6.
1 times 9 and 3 times 3. So if I say what are the factors of 9, I would say 1, 3, and 9.
You said 6. Oh, I didn't. You did.
So 3 or more factors, all of them. basically any composite number will be divisible by something other than itself, 2, 3, whatever it may be here. Even numbers. All even numbers except for 2 are composite. 2 is a prime number. It's the only even number that's prime because the only things that can multiply to 2 is 1 and 2, right? There's nothing else. It only has 2 factors. But any other even number like 4, 4 times 1, 2 times 2, 6, 6 times 1, all of them are composite. They can be broken down further. So the prime numbers you really want to be familiar with, 2, 3, 5, 7, 11, and 13. Those are the most important ones because anything we break down is going to turn into one of these 6 numbers. And I guess 1, 2. So there you go, one of those 7 numbers. So we will see these combinations a lot here. But difference between prime and composite numbers for prime factorization, we will take essentially a composite number and turn it down into a whole bunch of prime numbers. It's prime components. So let's shift over to notes. We're done with vocab for today. Prime numbers, composite numbers. I use those terms a lot this chapter, both of them. Okay. So we don't cover this concept, but we did in 5th and 6th grade. First part says, is the number prime or composite? So number 3 says the number 19. Is that prime or composite?
Oh, prime.
Right. So I would just write prime. Number 5, the number 74. What's that?
Composite.
How do you know?
Because it's an even number.
Huh?
Even.
I know 74 times 1 has to be something, but I know it divides by 2. So as soon as I get that third number down, that's all I really need to know to prove composite there. There's could be more factors than this. I don't know. I don't think there are, though, because 37's prime. That's it. Some numbers you may not necessarily know on first glance, like, I don't know, 74,
1, 2,
83. What do you think 83 is?
80. Yeah, prime. Or no, prime.
So, understanding the rules of divisibility are helpful. How do you know if something divides by 2?
As if it's even.
It ends in a 0, 2, 4, 6, or 8 in the ones to come. I know if something divides by 3.
It's if you add it and if that's divided up into 3.
Right. So 528, does that divide by 3?
No. Yes. Yeah. 15.
So to know if something divides by 3, what I do is I add up the digits. 5 plus 2 plus 8 equals 15. And does that divide by 3?
Yep.
Yes. So 528 does divide by 3. Number divides by 4, you look at the last 2 digits. 0, 4, 0, 8, 12, 6. If the last 2 digits are a multiple of 4, there's 24 of them. 0, 4, 0, 8, 12, 16, all the way up to 96, then it can be divided by 4. 5 is easy, ends in a 5 or 0. 6 divides by 6 if it divides by both 2 and 3. So, understanding at least probably the 2, 3, and 5 rules of divisibility will probably get you through this. Main thing you want to be looking for is 3. But you're going to be presented some new things. Magic number. This number right here,
Q.
91.
Oh,
Is that prime or composite?
Wait. Composite.
What times what?
10. No, not 10. 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 Wait, I'm cooking here. 7. 7.
Right.
Yeah!
Keep this number in your mind. Write it down if you want. It's going to be the one, you will see it once or twice along the way here. But it's weird because none of the rules of divisibility work for this number. Doesn't divide by 2, doesn't divide by 3, doesn't divide by 4, doesn't divide by 5, doesn't, so you're probably thinking, well, probably prime. And I wouldn't blame you. But there are no rules for 13 and 7, so 91 kind of slips through the cracks a lot.
Gotta guess.
It's just you'll see it again, I promise you. This exact number. Any other number, use your 2, 3, or 5 rule of divisibility to figure out prime or composite, but 91 is a special number. So, because it's just none of your rules are going to work on it. So.
Me and 90 would have a lot in common. We're both special.
This number right here. Okay? 91. Remember it. Anyway, good with the first part there. Just prime or composite, right? Easy. All right, second part. So, we're going to be building trees here in a minute.
Christmas tree.
Prime trees. Let's look at 17. So it says, what they've basically done is this was a number, and they built the trees, and then when they finished their trees, here we are, like here's 528, and when they broke it down in its prime components, this is what it turns into right here. So what do they want us to do? This is not how we normally write it here. Again, they kind of keep it going here. 2 to the 4th times 3 times 11 is what 528 is. This is the final answer. So what they've done is they've broken down the tree. This is it. But you're going to want to get used to, and a lot of this stuff is written in exponential form. So 17 says 2 times 7 times 7. And they want us to do 2 things. 1, write it in exponential form. And then 2, solve it.
To the second.
Huh?
So 2 times 7 with a 2 above it.
Right. And again, the order you write this stuff doesn't matter. You write 7. But this is what we're looking for. You can, however you represent it. But this is my answer for that part right there. So the exponent tells you how many times you multiply the base times itself. The base is 7. I'm multiplying 7 times itself 2 times. So here it is in exponential form. If I solve it, 98. So there's the 2 things I'm looking for here. 2 through 30, you don't need to write any of this stuff out in your notes. So unlike your most recent, those last homework assignments in chapter 4, you're back to a easy one's going to start. So, right, the equations and stuff that you had to do. So 2 through 30, I'm not looking for really much of anything. It should be pretty fast and easy. How would I write out number 27? Write this one in exponential form. So write in an exponential form, then find the product.
Okay, so 300.
So Faith, if I write it in exponential form, how is that going to look?
5 to the 2.
5 squared
And then 2 to the 2.
times
Yeah, times. And then 2 to the
2
2.
squared
And then times 3.
times 3. Right. So there it is in exponential form. 25 times 4 is 100. 100 times 3,
300.
300. So again, for this part here, looking for 2 things. Write it out in the exponential form. Solve it. Easy enough. The first lessons of the chapters are always usually pretty easy. Good with this? Okay, now let's get to the real stuff here. So it says on a separate sheet of paper, So what am I looking for from you? Draw two. I don't need two different factor trees. That's ridiculous. I would like you to make required. All right, I won't require it for everyone, but you are required to do trees for 34, 36, 38, 40, and 42. They are required for those three.
Okay.
We have more problems to do, but I will let you, some you can do in your head or whatever, that's cool. But these four, you need to make a tree in your notes, homework. You should have plenty, okay? Do not do it in your book here, there's no room. So just speed up the process and get your homework right in the notebook today. But these four, make a tree, okay? Make a tree. Let's look at number 33. And it says, all it says is the number 45. And what it wants us to do is in prime factorization. So the number 45 is a composite number. A lot of things that divide into it. 1 and 45 goes into it. 3 and 15 goes into it. 5 and 9 goes into it. It's got 6 factors.
3.
Yep, 3 and 15.
Oh yeah, my bad.
So to start this here, what we're trying to do is we're going to turn this all into prime numbers. And remember your prime numbers, 1, 2, 3, 5, 7, 11, and 13. So my answer here, when I get to this part here, can only have these numbers in it. If I have other numbers like 4 or 6, well, 4 goes down farther. 4 should be 2 times 2, or 2 squared. 6 goes farther, 3 times 2. If you have any composite number, you have to keep going down until there's nothing left but prime numbers. So I'll do this a couple times here. Writing 45 and 1 down doesn't get us anywhere. So I need to pick something else. I'll pick 15 and 3. So what I'm trying to do with 45 here is think of any two numbers that multiply together and form 45 besides 45 and 1. And I've chosen 15 and 3. So from here, the 3, that's prime, right? That's done. But 15 is composite. So 15 I can break down further, which turns into 5 times 3. Agreed? So my tree here it is. Prime number, prime number, prime number. So if I wrote this out in exponential form, how would that look?
3 times 3, 5 times 3 times 3.
Exponential form.
Yeah, 3 squared times 5.
Yeah.
That's my answer. Or, again, it doesn't matter. You can do it this way too. Both are fine. The order doesn't matter here, so. But this is it. And I can check it. 3 squared is 9. 9 times 5 is indeed 45. If I went this way, say I went 9 and 5, which is probably what most people come up with. But then we know 9 breaks down farther. It turns into 3 times 3. And if I look at what's left here, it's the exact same numbers. It's still 3 squared times 5 on both of them. So what am I showing you here? Well, you can get to the correct answer a variety of ways. Personally, I believe that just dividing by 2s, 3s, and 5s, if you can get a bigger number than that, hey, that's great. But just getting down with that, let's look at 35. It says 1,575. Now, right off the top of my head, I don't know what the greatest common factor of that is. Probably, 25 probably goes into it. I'm sure it does. But maybe 125 does too. But what I do know, at the minimum, is it divides by 5, right? Doesn't divide by 2, it doesn't divide by 3, but it certainly is going to divide by 5. And that's fine. I'll just start with that. And then I end up with 315 times 5. Perhaps you have a different number. I don't know. But 315, now that's a prime number. That's going to be part of my answer here. But the 315, that can go farther, right? And once again, I don't know everything that divides into 315. What I do know is it divides by 5, though. So now I end up with 63 times 5, right? 63, composite number, I can break that down further. How about 9 times 7?
Yeah.
That's prime, but this is composite. That needs to go farther. So when it's all said and done here, there's my tree. It's basically this. And if I wrote it out in exponential form,
3 squared times 7 times 5 squared.
right. And that is my answer there. 3 squared. Again, however the order is, however you want to do it there. Okay. Why don't you guys try building your tree for number 37? You build a tree. 42.
No, say that again. Oh, it's the easiest one. No. No.
So, build your tree and write your answer in exponential form.
I don't care how old I get, I will forever write multiplications in the little x. Yeah.
Yep, that's fine.
The only other acceptable one is the little star thingy.
So, Eve, what did you get for an answer?
3 times 2 times 7.
Right.
That's
And 21 and 2? Or 7 and 6?
I got 7 and 6.
Yep.
I did 6.
I picked something most of you probably didn't, but maybe, I don't know what you picked. But, yep, you can use, of course, 7 and 6, and then the 6 turns into 3 and 2. There it all is right there. So, easy enough. These here, again, you can use your trees. I don't really care. I need you to do, as I said, I'll have you on the quiz. I'll require 1, maybe 2 trees. Ditto with the test, 1, maybe 2 trees. That's it. But by no means does that mean don't use the trees anymore. For some of these here, again, depending on the numbers, how well you know, what you're up to, you very well may want to consider using more trees. I'm just requiring a few just to see, but depending where your math is and things like that, some of these you may be able to do in your head and some you may not. You need to make your own choice on what you need to do to get to the right answer. Make sense? 45. So, prime factorize it, exponential form your answer.
Okay.
Most of these you'll probably need to make trees for, but the prime factorization is useful for larger numbers when you're, because we're going to get into simplifying fractions and stuff like that, so we're going to need to be able to divide things and write equivalent fractions, and we'll need to know common factors and stuff. So the next 2 lessons, greatest common factor, least common multiple, both of them employ factor trees once again. But what we do at the end of the tree and how we solve is going to be different for the 2 methods. We covered this concept last year, so it's not, none of this is new, but. All right, Faith, what did you get?
64 times 1. Do you want like the tree?
What did you get for an answer in the end?
In the end, the 64 times 1 beat times
what's my answer in exponential form?
2 to the 5.
Right, 2 to the 5th power is correct. So, and again, 64 has so many factors, but however you get there. So what am I left with here? There it all is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 4, 8, 16, 32. Oh, you forgot that 2 right there. 2 to the 6th. 6 of them. So 4 times 2, there's 2, and then the 4s all turn into 2 times 2. 1, 2, 3, 4, 5, 6. 2 to the 6th. 2, 4, 8, 16, 32, 64. There it is. 2 to the 6th.
Looks like an airplane. Hey.
Give you each one to do, and then we're done. 47, 49, 51, 53, 55. Eve, which one do you want? 47, 49, 51, 53, or 55? Sam, which one do you want?
47.
Which the ones? Oh,
Eve, you're doing this one. Okay, Sam,
Which ones do I get to choose?
49, 51, 53, or 55? 108, 34, 240, or 286?
51.
51.
Is that an option?
34, sure. Faith? I guess you got 108, 240, or 286.
49.
Okay, 108. All right.
I done.
Use trees, whatever you got to do here. Try all 3 of them.
Mine's not very hard.
None of them are very hard,
That's
but
fair.
last 3. Do try all 3. The next 2 lessons will be expanding on this and actually apply it to something we need to do. So today, if you can understand the difference between a prime and composite number, understand composite numbers need to get broken down further. I gave you a list of what all the numbers are that you're interested in. If you look at any of our answers, 2 to the 6, 3, 7, 5, 3, 7, 5, any answers, it's only going to have these numbers. They may be squared, they may be cubed, who knows, but these are the 7 numbers that you're going to come up with. And I guess technically you won't even really have 1 in any of your answers, so 2, 3, 5, 7, 11, and 13. Every single number will turn into some combination of those. Okay, let's do it. Break me down the tree. Who had 47?
Me.
All right, let's do it.
So 10 times 5.
Okay.
And then you can simplify 10 to 2 and 5.
Okay.
And then that's it.
Well, what's my answer in exponential form?
5 to the 5
5 squared.
or 5 squared.
Time.
And then times.
Right. That's my answer right there.
Ah.
Make sure to get them in exponential form. 34, who had that one? All right.
It's 17 times 2. There you go, that's the answer.
That is the answer, and that's all there is to say. Exciting. Faith?
2 times 54.
Yep.
And then 54 is 2 times 27.
Okay.
And then 27 is 2 times 9. It's
3 times 9. Okay.
And then 9 is 3 times 3.
Good.
And then it's 2 to the 2
Okay.
times 3 to the 6.
That's it. That's a 3. 3. 3. Yep. There we go. 2 squared times 3 cubed. Bada bing, bada boom. Questions?